Launching cargo and crew dozens of times, with 5 times being reused, might sound ordinary if you stand from SpaceX's perspective. But it's something that SpaceX competitors Soyuz and Starliner cannot achieve. Soyuz launches frequently, but lacks reusability, while Starliner is still struggling to launch its first crewed flight. Therefore, after SpaceX conducts Crew 8 and undocks Crew 7, I believe now's the appropriate time to discuss Dragon's reusability and how SpaceX humiliated its competitors. Let's find out in today's episode of Alpha Tech. The space frontier can't be settled with throwaway rockets and spacecraft. Recognizing this and pursuing a philosophy of reusability, SpaceX has achieved remarkable milestones throughout its tenure. By safely ferrying astronauts to the International Space Station aboard a previously flown Dragon spacecraft, SpaceX has demonstrated the capabilities they deem essential for significantly reducing the extraordinary costs associated with human spaceflight, while also contributing to ushering in a new era of autonomy for the entire U.S. aerospace industry. Dragon has set numerous records for SpaceX, including the first crewed flight to the ISS launched from U.S. soil in nearly a decade, the first privately piloted mission with a citizen in outer space, and the first spacecraft capable of near-complete reusability since the shuttle era. One might wonder which spacecraft today could achieve such feats: Soyuz or Starliner, perhaps even Orion, yet none have. And while Dream Chaser aims for reusability, it has yet to fly. To date, SpaceX's Crew Dragon spacecraft completed its 13th crewed mission, ferrying 50 astronauts to Earth's orbit. Business activity is booming for SpaceX's Dragon program, with flights occurring more frequently than anticipated due to delays with Boeing's Starliner spacecraft. This underscores the increasingly vital role of Crew Dragon and its necessity for all government-sponsored human space missions. However, with the latest flight of Crew Dragon, NASA's Crew 8 mission, SpaceX's Crew Dragon Endeavour has reached the milestone of its 5th flight, the maximum number of flights that a qualified Crew Dragon spacecraft can undertake. What comes next? Will it have to halt its journey? No, certainly not. It'll fly again. This will not mark the end of Endeavour's spaceflight career, because NASA and SpaceX are striving to certify each Dragon spacecraft for up to 15 flights. SpaceX has 4 Crew Dragon spacecraft ready for reuse in its inventory, with the 5th slated to join the fleet later this year or early next year. This fleet's sufficient to meet the demands of NASA's crewed missions and commercial customers until the end of this decade. But this spacecraft, what NASA and SpaceX refer to as the Fleet Leader, could potentially prove itself worthy of more flights, possibly many more. According to NASA officials, Crew Dragon might be able to fly up to 15 times, depending on the results of a requalification campaign the agency and SpaceX will undertake this year and next. Once the Endeavour spacecraft's expanded in terms of reuse, surely the remaining members of the Dragon family will have the potential to shine like their siblings. During a press briefing on February 28th to discuss the Crew 8 mission, Steve Stitch, program manager for NASA's Commercial Crew program, said SpaceX is currently performing qualification tests of every single component on the Dragon spacecraft to determine how many flights the spacecraft might be capable of making. They'll examine the structural framework, composite shell, rocket engines, valves, and other components of the Dragon to assess the remaining lifespan. Some parts of the spacecraft gradually wear out due to the stress of each launch, re-entry, and landing, along with the harsh temperature changes the capsule must endure thousands of times in orbit. Each Draco thruster on the spacecraft is certified for a number of things. We are right now embarking on what we called our extended Dragon certification, Stitch replied to a question during the briefing. We're working on that this year and probably next year to see how long they'll fly Dragon. By recertifying the quality of a component on a spacecraft typically involves subjecting the hardware to extensive ground testing. Because SpaceX reuses hardware, engineers can remove a component from a flying Dragon spacecraft and put it through quality testing. Therefore, when the Crew Dragon Endeavour mission concludes and returns to Earth, NASA and SpaceX will analyze various components of the spacecraft that have been exposed to the space environment up and down for many years. Despite numerous flights of the Crew Dragon, there are still some recurring issues in reality, which can be somewhat challenging for the extended certification process of the Dragon. Specifically, this is the phenomenon of valve corrosion in the oxidizer valves of the spacecraft, both on the low-pressure side, which is used in orbit, and then on the side for aborts. The underlying cause of this corrosion is the Draco and Super Draco thrusters consuming a hypergolic propellant mixture. Hydrazine serves as the fuel, while nitrogen tetroxide acts as the oxidizer, and they ignite upon contact with each other. Although SpaceX has their technicians regularly replacing various types of valves on the oxidizer side of the propulsion system, including the tank isolation valves, Draco thruster valves, and shutoff valves for the Super Draco engines, space remains harsh and unpredictable. In fact, valve issues are not unique to SpaceX, but are encountered by other space companies as well. Boeing encountered similar valve corrosion issues with their Starliner spacecraft. Investigators determined that the problem was caused by the reaction of nitric acid with moisture infiltrating the propulsion system. SpaceX seems to have detected evidence of valve corrosion early before it escalated into a more serious problem that led to the suspension of Starliner's test flight for nearly a year. But there's no need to be overly concerned about this because not only has SpaceX identified solutions, but they're also banking on the Starship, a promising next-gen vehicle slated to entirely replace the Crew Dragon and Falcon 9 in a few years. Eventually, Starship will also receive NASA's human certification, allowing it to transport dozens of crews into Earth's orbit. In essence, the criteria for Crew Dragon and crewed flight certification will likely apply similarly on Starship. So, how did Crew Dragon go through the certification process? Being a human-rated spacecraft has proven to be a lengthy journey. According to Ed Mango, former director of NASA's Commercial Crew Program, it's a rigorous process that can take months. Before any hardware was built, SpaceX's Crew Dragon capsule was subjected to a series of design reviews to ensure that it met fundamental requirements outlined by NASA. The agency provides high-level specifications, but the details of the certification process are different for each vehicle. The commercial crew concept was that NASA will define the safety and performance requirements at the highest level they can and let the partners innovate and design the system that can meet those requirements, says Mango. For example, all human-rated spacecraft must be capable of being manually and remotely controlled, even if spacecraft is usually almost entirely automated. NASA certifies a spacecraft based on the fundamental design of the vehicle as well as the missions it's designed to perform. A vehicle to take astronauts to the moon would have to meet a different set of requirements than one carrying into low Earth orbit. Thus, the first part of the design process involves simply identifying the needs of the mission and designing the spacecraft to meet them. For example, since Crew Dragon will be used to shuttle astronauts to and from the space station, it needs to be able to interface with its docking points and survive in space for at least 210 days. During the design process, NASA and its contractors also had to agree on a flight test program that would demonstrate that each spacecraft works as intended. For some tests, NASA let the companies decide how they'd be conducted. For example, SpaceX and Boeing had to prove that in the event of an emergency, their spacecraft could abort a mission and carry its crew safely. Both companies completed pad abort tests, which involved firing the escape thrusters on a crew capsule while it's still on the launch pad. But only SpaceX conducted an in-flight abort test and jettisoned its capsule from a rocket during flight. Boeing opted to do simulations of an in-flight abort test based on its data. Other aspects of the flight test program were non-negotiable. For instance, NASA often requires that for every crewed flight, there must be uncrewed flights to the space station. Even though these missions are unmanned, they still demonstrate the core functionality of the spacecraft. Subsequently, the company still needs to send some people on board to prove that they can accomplish everything as planned. The extreme rigor of NASA's human rating process stems from the agency's failure is not an option ethos. As outlined in the agency's official certification documents, the human rating is less of a process and more of a mindset where each person feels personally responsible for their piece of the design and the safety of the crew. That's a significant responsibility for engineers to bear. But it can be said for SpaceX's Crew Dragon, NASA's placed full trust right from the successful Demo 1 mission in 2020. But what about Starship? With its capacity several times greater, will this process become even more challenging? Please share your opinions below in the comment section. That's all for today's